not so much about mistakes in rigging mechanical advantage systems or errors, more so of just inefficiencies. So let's just start with a Prusik minding pulley and a Prusik rope grab. So when we first rig this up, if we're going to rig this up this way, pay attention to how I stacked the equipment inside the carabiner. So I put my Prusik in first, and then the pulley on top that's going to mind the Prusik. So when I haul up, it sags low, and it's not the other way around. So this isn't up here and it gets tangled up. So some people do that. This is just a little cleaner when you start to haul this way. When people start to build their mechanical advantage systems, let's just say they start with the intent on building a 3-to-1, and they use the entire throw to build their system, and they end up saying, okay, we're gonna take this bite all the way out and we're gonna start building my 3-to-1 here, and then I'm gonna build a 5-to-1, and they're just dragging a lot of rope over and over and over, and it's very confusing and gets all the lines tangled. So that's another error, is building your mechanical advantages to the entire throw first. The better way is to build the mechanical advantage small and then extending out to the entire throw. That's a much better way to do it. Also, a lot of people will build their mechanical advantage first without ever considering taking all the slack up. They'll rig their mechanical advantage and then start hauling, and they're hauling out all this dead material. So before you rig it and set your mechanical advantage, just hand over hand, get your device taut, get everything taut so that you aren't wasting your throw on just taking up all the slack out of your haul. People that think that, okay, we're gonna start off with a 3-to-1 and maybe I'm gonna put in this double sheet pulley just in case I can convert to a 5-to-1. The error here is never use a double sheet pulley unless you're gonna utilize both sheets, because you start to pull off access and this rope starts to rub against the side plate. So if it's just a regular 3-to-1, don't use a double sheet pulley. Just use a single sheet pulley and then convert if you need to. So if you know you're gonna go with a 5-to-1 straight out the gate, well, inefficiencies I see is when people start to bend this through, they want to keep everything nice and S-turny. So this tension line comes in through our first change of direction after the capture, and it bends back to an S here, and they want this thing to bend back again to an S. And then we hook this in, they want this to bend again through an S. But what we really should be doing when if we know we're gonna rig like a 5-to-1 like this right out the gate, as you can see, because of all these S bends, I've crisscrossed all these lines, and the longer this throw is, the more friction rub points exist. So if I know I'm gonna build a 5-to-1 right out the gate, like a simple 5-to-1, instead of doing a series of S turns, even though intuitively it kind of makes sense, consider making circles instead. And when I say make circles, what I mean is this first line comes down, and whether you make an S here or a circle here, it doesn't really matter, but once you pass this first pulley, continue to make circles. So my first one is an S, but here, instead of making another S, I'm gonna make a circle. And we're gonna route this through as a circle. And that just cleans up all our strands. So everything, there's fewer crisscrossing in my mechanical advantage system. They wanna rig a 3-to-1, and they only have a pulley for your initial change of direction here, and they only have like another pulley, and that's it. And so this is all they have, but they're struggling because they have to haul uphill on some uneven terrain. They'd rather use their body weight to haul downhill. And what they end up doing is putting a change of direction in the form of a carabiner. And the problem with putting a change of direction in the form of a carabiner on your last change of direction is you drastically reduce the actual mechanical advantage here. There's this thing called the capstan equation, and like the big thing is the exponential like increase in friction based off of the angle and the coefficient of friction between the material and the rope. We can't change the angle because we want to haul back this way, and so what's really destroying us is this coefficient of friction here. It's a 50% hit. When you T-method this out, it's not one in, one out. It's one in on my hand, it goes through, it loses half, and it's half out, 0.5 instead of 1, and that compounds because now I get to 0.5 in, and then 0.5 out, and only have 1 here instead of 2. And so when I do my mechanical advantage, sometimes like I drastically take a hit by putting just a carabiner as my change in direction. So let's think about this. I want the highest efficient gear in terms of pulleys needs to be closest to the haul team. And if I only have 2 pulleys, maybe I should consider doing something more like this. I'm gonna loosen this up. Let's get rid of this, because we have a high efficiency pulley that's right at the anchor on that change of direction. And let's just put that into the carabiner and then use this as my change of direction. My final change of direction is the high efficiency pulley this time. It's a 3-to-1 with a change of direction, but I don't take a 50% hit. This pulley is pretty efficient. Let's just say in testing it was 90% efficient. So it's not, again, it's not 1 in, 1 out. It's 1 in, I take a 10% hit, 0.9 out, but that's a lot better than 0.5. So if I'm gonna do a final change of direction pull with limited gear, put all my carabiners closer to the load and then build my pulleys closer to the hauled side, because then the friction will compound less and it will save me in the end. So, and again, if this is not good enough, then I can always turn this into a complex system, making this pulley move into a complex. So the haul. So you get a haul team. If I haul straight back like this pulley, it's not traveling, it's not doing anything. This is a 1-to-1 change of direction in theory, and there's no mechanical advantage here. I only start generating mechanical advantage the second that I engage the sheave and I start to make it act like a little internal lever. I'm only getting that mechanical advantage when I haul a full pi or 180-degree bend back towards me. And I see a lot of people hauling out here at this kind of 45-degree angle. They're not getting the full lever effect, that full 2-to-1 lever in here to maximize their hauling efficiency. I need to make sure that I haul a full directional back in that direction. So it has to go in 180 degrees all the way back. So we're gonna throw an MPD in here. It can be a maestro or a clutch, but I just happen to have the MPD right here. And so when we rig these MPDs up, aside from the fact that they're overly kind of complicated to rig, because when I do this I got to figure out, okay, that's ultimately going to be attached to the becket. I got to figure out well, I know that my brake strand is going to come out on this side, and the question is I have to give some serious thought into how I want to operate this, because I don't want to clip this in and then end up having to torque on my anchor because I want to have my ropes or build my haul system to the left or right. I have to go one direction or the other. I have to build my haul system out here, since this is the brake strand of the device that comes on this side of the device and not that side. So the load comes in through here. Sorry, let's load this up. Okay. And I see people that aren't really thinking about this all that much, and they clip in. And now, if we want to keep our anchor straight and everything straight, we have to build our haul system over on this side. And I see people wanting to switch up and build the haul system over on this side, and they twist everything up and everything just kind of gets confusing and disorientating. So be cognizant of where you should build that haul system before you hook in. Or better yet, I know it's expensive, but the swivel is an awesome choice, because now it does not matter one bit. I hook in and it doesn't matter how I oriented my ropes, I can always untwist or whatever. So the swivel is awesome for that application. Unfortunately, they're a little bit pricey. Let's put an anchor plate in here. Whenever I build a system, having an anchor plate, if you have one, is a great idea, because if you need to build out mechanical advantage, it's super easy. And so instead of having a carabiner that has no twist in it, let me get rid of all these and go one more. And what I'm going to do is build this with a swivel into the anchor plate. And then wherever, the question is, where do I hook my device? Well, the brake strand is here. This is also the haul strand on the mechanical advantage system. So if I know that I have to build my haul strands to this side, I want to clip right there with a carabiner. And now, depending on space, I can operate a lowering system out here on this side and then convert to a haul system and realize that I need to have my haul field over here, and then just rotate this whole thing without having to take any gear off. And now I can start to build my mechanical advantage system with changes of directions, or directionals if I'm going to do like a bat wing system, out this way. So swivel beaner to anchor plate to your device that has the brakes side or the haul strands coming out towards the available holes. That will set you up for success or more efficient rigging every time. Just little things you can do to clean up your rigging. There you go.